What's up guys, my name is Saib and welcome to another episode of this series. And in this episode we're going to talk about two important terms that are usually associated with game development. The first one is the game loop. A game loop, think of a game loop as an overall flow of the entire game that we're having, such that it has a code, it's a bunch of code that keeps looping or iterating at a certain frame rate. For instance, like if we're using the request animation method, which we will be using with the game loop, the game loop function will repeat 60 frames per second, which means if every frame takes about 16 milliseconds, 16.67 milliseconds for instance. And yeah, so it keeps updating the code over and over, and each iteration of this game loop is called a frame. So yeah, that's simply it. It's a function that keeps repeated at 60 frames per second. It takes the input, it deals with handling inputs and then updating the objects in our game and simply drawing them. So if I started to load some asset, for instance, to make it move, and then introduce the game loop function. So the first thing I'm going to do in here is simply use our loader. We've talked about we're using PixiJS as well, so we have our render in here which auto detects, and by default, as I said, it's going to take the WebGL since it has full WebGL support. And then I'm resizing the canvas using the resize methods, and I gave it a background color. Make sure that this is a hex value 0x instead of a hash, but it's exactly the same values. If you're not familiar with color formats or color values, there's an episode for colors. You should definitely check that one. And simply now we're gonna append our canvas tag simply by passing an append child to the body of the document. And this render review is simply a plain canvas tag that you're gonna see in. If I looked in here, you're gonna see now that in the elements, this invoked canvas element is injected into this HTML document using this append child, and this render review is simply a canvas tag, a plain one, so we can style it the same way. And I gave it a 1 pixel dashed black border, for instance, like this one, using that styled border. And now we're having our scene, which is simply the same as the stage. It's just a container that contains all of the visible things that we're gonna see in our game or in our canvas. And as I said in the previous episodes, Pixi requires us to have one container, so that the render has to render one thing, which is this scene, with all of the visible things added as a child in this scene, or as an actors for this stage. And yeah, the loader simply load our assets, our images for instance, and everything, and the resources to access all of them. If you're not familiar with anything that I said, you should definitely check the previous two episodes, since I gave an introduction to PixiJS, which is an API, and yeah, Pixi's API. So okay, so let's try to load our spaceship. We're gonna use the same spaceship that we've been using since the first episode. I don't know why I didn't change that, but it's fine. Okay, let's just close that one, and simply I'm gonna access our loader, and then I'm just gonna say add. I'm gonna give it a name to refer to, so it's gonna be spaceship, and then I'm gonna pass in the location of this spaceship. It's in my assets folder in this fun with canvas directory, so it's gonna be assets and spaceship.png, so, and then I'm gonna load setup. So this is the chain methods in JavaScript, which means it's gonna add this assets and their sources, and then it's gonna load this setup function. So I'm gonna come up with a definition for the setup. You can call it draw or anything, but it's not gonna actually draw. It's gonna set up everything, and the game loop will draw everything. That's why I'm telling you the game loop controls the whole flow of our game, entire game. So yeah, now let's make a global variable for the spaceship sprite, for instance, so that we can access it in all of the functions, so we have more flexibility of it. And then let's define the spaceship texture, for instance. We define this in the function since we're not gonna use it. We're only gonna use it to make a sprite for the spaceship, so that we can draw sprites in our Pixi in our canvas, for instance. So yeah, what I'm gonna do now is access the resources. Since I loaded my spaceship and it's in the resources now, I can access it by calling the name that I gave it to it, which is a spaceship, and I can convert this to a texture by calling the texture method like this. Since, as I said, WebGL ready images are textures, so we have to convert all of our images into textures so that we can actually draw them and render them. And yeah, now let's initialize the spaceship sprite by making an instantiation of the sprite object in our Pixis API like this, and then we're gonna pass in the texture for this image. And now we have to draw our spaceship sprite so that we can actually see our spaceship into our canvas. Let's center this spaceship, for instance, by simply going to the X and Y values. And if I want to center this, simply I'm gonna need the render view, which is our canvas. As I said, this is just a plain canvas tag, and it's gonna be the width divided by 2, and I'm gonna minus the half the width of this spaceship sprite, since, as I said, the top left corner of this image, let me just show it to you again, the starting point which is the top left of this image. So if I want to center it, I'm gonna minus half the spaceship width. We've gone through that a lot. I hope that makes sense. It's gonna divide by 2. The same thing goes for the Y, but now for the Y we're gonna use the height. It's gonna be render.view.height divided by 2 minus spaceship.sprite. I don't know why it's height by 2, for instance, like this. And now I can simply add it as a child in our scene so that we can actually see it when we render the scene. And I have to pass it. Okay, and then I can just render that to actually see, to make sure that everything is working fine, and yeah, the scene now, which is simply the stage. It's exactly the same thing, it's just names. Now if I looked, I can see my spaceship in the center of our canvas. Everything until now works exactly the same as we did in the previous episodes. The new thing, which is the game loop, so I'm gonna make a function. I'm gonna call it game loop, and this game loop function will take all of the code that will get updated every frame or every iteration, every 16.67 milliseconds if we're having a frame rate of 60 frames per second, which we will, since we're using the request animation method. And this request animation frame method, we've worked with this in the animation episode. If you're not familiar with, if you haven't done animations before, you should check that episode. It's just for absolute beginners. And yeah, and we've talked about this request animation frame, which is a JavaScript built-in function or method. And this request animation frame, if we pass a function in here, which is the game loop, it will update all of the code in this game loop at a certain rate that matches the monitor's refresh rate, the monitor that you're actually using. But by default, and mostly it uses 60 frames per second. So each iteration, as I said, takes 16.67 milliseconds. And yeah, it's gonna keep stuck in this function and it's gonna loop its code. So since I'm actually, when I get into this game loop, so I'm gonna just remove this render and I'm gonna pass in the game loop like this. So after I load everything in my spaceship and I center this spaceship, I add it into my scene, and then I'm gonna access the game loop. Now I'm just gonna be stuck in the game loop. It's gonna iterate at a certain frame rate, as I said, and yeah, it's gonna keep looping until the player uses everything, until something that we actually specify. So in this game loop, I'm just gonna render my image, for instance. I'm gonna render the scene so that I can see my spaceship, and yeah, I'm just gonna stuck on this spaceship. So if I want to move it, I can simply update the axis position of the spaceship +1, for instance. Now I can see it moving with a smooth animation like this. Okay, that is simply the game loop. It's just the overall flow control of the entire game. And the way that we're actually structuring our code to using the game loops, since if we're actually building a game, we're gonna take inputs. So handling inputs is gonna be in the game loop. Now updating the positions of every object, or updating anything that's related to the actors in our game, or simply the objects, and then draw them. So it's gonna be taking input, for instance, taking inputs, and then updating, and then rendering or drawing to the screen. I hope that makes sense. So now if I introduce some velocity for the x to represent the displacement of this object, so I can say a spaceship sprite.vx for instance, and give it 1, and I can just vy, which is velocity for the y, as I said, represents the displacement of this spaceship, so I can now apply this by 1. Now this spaceship velocity x is gonna it just represents the speed and the direction of this spaceship sprite, so I'm gonna move by 1 in the x direction, which means horizontally. So yeah, and this is just an introduction to the physics episode that's coming after this one, where we're gonna do the acceleration and the friction and apply some gravity to the objects so that it feels like a real life simulation of this. So yeah, and simply now I can just introduce the speed for the velocity and the x in here so that it moves faster. And okay, that's everything about the game loop. I hope that makes sense and you actually have like a good foundation in a game loop and you understand what exactly is a game loop. And now lastly, we're going to talk about the game states. A state is simply just it's going to be a function in here, a variable for instance called state, and this state will point into a certain function or a certain state in our game. And we use states to represent the levels and the scenes of our game. So for instance, I want the first state, which is play. In this play state, I want it to actually move the ship the same way that's actually moving, like this one. Now the spaceship is moving. I just slow that one down so that we can see it. 0.2 for instance. Now it's gonna move. This is the play state. And for instance, I can have different states, which is game over, like this. So let's start by play. Now this state will point to play, which is simply a function, and both of them are functions that this state will be point to this function play function. And yeah, we can change that simply in the setup in the game loop. So I can just remove that and I can put it into my play function like this, which is simply gonna move my ship, and I can call the state function like this. And as I said, we use the state to switch between our game scenes and levels. So I want this scene now to be the play, to actually move my ship. So since the state actually points to the play function in here, it's gonna call the play 60 frames per second, since this game request animation frame loops around this one. So every time I call a state, it's gonna call this play one and render that one, then goes back again. I hope that makes sense. It's a loop that runs at a certain frame rate that matches the monitor's refresh rate, which is by default, I think it's 60 frames per second. We can use the ticker of Pixi's ticker to actually access that one. I'm gonna show it to you in the next episode, since now I didn't tell you exactly how to draw texts with Pixi. So yeah, I'll leave that to another episode. So yeah, now we're having this play state. Let's say that I want to change this to game over, for instance. So I can alter the scenes. I want a game over scene, so I can come up with and define this function. I'm gonna call it game over. And okay, let me show you how we can actually draw texts with Pixi. The first thing, I'm gonna define a variable, and then it's gonna be an instantiation of the text object in Pixi's API. So it's gonna be new Pixi, same as sprite, but now it's actually text, and it takes 2 arguments by default. The first one, which is gonna be the text, so let's say game over, and the second one is gonna be an object, which is a standalone entity, as I said in the previous episodes, the objects one. And we can just alter some of the properties. For instance, I want the font to be, I can just have string now, and I can just say 90 pixels, and I want comic as for the family font. And now the fill, for the fill color, I can just say red, for instance, like this. And I can add this message into our scene so that we can actually see it. Again, every visible thing or any visible things that you want to see in your game, you have to add it into our scene. Since the render renders the scene, renders one thing only, which is the scene. And this scene contains all of the visible things that you have. So it's gonna add a child, and it's gonna be the message one. So since I altered the behavior of this state, since I changed the game state or the game scene, now it's gonna point to the game over. No ship gonna be, but we're gonna still see the ship, since we actually set up that ship. We can change that later, but you're gonna see now that we're having this game over. Or simply we can change that by moving and into the play. For instance, I can just say play, and I can move my ship, and I can make a condition in here before we actually move. If spaceship sprite.x is bigger than the canvas, simply in our case, which is the render view width, we can call the game over. And I have to center this one, same way that we did for spaceship. We can just go to render view, but I have to change for the sprite, of course, it's going to be the message in our case. And for the width, the height, I mean, message dot height, it's going to be exactly the same, but for the height now, and this should be message. Now if I saved, you're going to see that when the ship passes, I'm going to make it faster so that we actually, so this, when it passes after this, it's bigger than the canvas width, we're gonna have this game over state. And simply, this is not the actual use of state. We can alter this by controlling where this state function points that we used in our game loop, and we can switch between our game scenes and game levels very easily. I want the structure to be exactly the same. I'm not gonna change it over the whole series, so it's gonna be the same. We have a game loop, and we'll have a state, which is simply the game scene that we have, or the game level, and we're gonna alter the whole behavior in our state, for instance, like this. And yeah, I hope this makes sense, and if you have any questions, please leave a comment, and I'll see you in the next episode where we'll go over physics and how we can simulate a real-life physics using PixiJS and simple mathematics, of course, and physics. And I'll see you in the next episode.